In one of our most successful journeys, we talked about rock patterns that occasionally tell prospectors they're standing above something much more valuable than ordinary stone. But after thousands of viewers watched that discussion, another question quietly remained unanswered. What happens when several of those patterns begin appearing together? Because experienced prospectors rarely stop after finding one clue. They become interested when landscapes start repeating themselves. Today, we're going to follow some of the most overlooked combinations of rock behavior that can occasionally persuade professionals to slow down, kneel beside an ordinary outcrop, and start looking much more carefully. And surprisingly, one of those patterns isn't even inside the rock itself. In our previous videos, we watched gold remain imprisoned inside resistant host rocks for millions of years. We followed nuggets through ancient pauses in transport, learned that gravity occasionally becomes tired of carrying heavy particles farther downhill, and discovered that landscapes quietly preserve clues long after the original mineralizing system stopped functioning. We even found ourselves standing in places most people crossed without hesitation, simply because the environment behaved differently than expected. But perhaps the most useful lesson prospectors eventually learn is that gold almost never arrives alone. Gold travels with architecture. Gold travels with disturbance. Gold travels with repetition. And repetition is what today's discussion is really about. Imagine walking toward an outcrop that appears disappointingly ordinary. There are no dazzling veins reflecting sunlight, no abandoned workings, no detector hole, no iron-stained cliffs advertising their history from a distance. At first glance, there seems to be no reason to stop. Then you notice something subtle. Several fractures are running through the rock, but unlike random breakage, they maintain a preferred direction. They repeat themselves. Some terminate abruptly against another structure. Others appear reopened. The rock surface between them is slightly recessed, as though weathering has spent more time there than elsewhere. Most people keep walking. An experienced observer occasionally slows down, not because they see gold, because they recognize organization. Nature is remarkably inefficient at producing order accidentally. When rocks repeatedly fracture in similar orientations, when weathering consistently exploits certain pathways, and when alteration selectively weakens only particular sections of an outcrop, geologists become interested, prospectors become interested, and sometimes, although certainly not always, those organized patterns are the first indication that fluids carrying dissolved minerals once negotiated their way through that piece of crust. Gold itself may be absent, but the pathways remain, and pathways occasionally tell better stories than gold ever could. Think back to our previous discussions. We spent considerable time following nuggets after they escaped their original hosts. Today, however, we're turning around and walking backwards through that story. Instead of asking where gold traveled, we are asking where gold once paused, where fluids once hesitated, and where rock masses still remember those ancient conversations. Because rocks have memory. Not memory in the human sense. Structural memory, chemical memory, weathering memory. A mineralized system can stop functioning tens of millions of years ago, yet its surrounding rocks may continue behaving differently today. Some become unusually brittle. Some weather into rib-like ridges. Some collapse into mosaics. Some preserve unusually competent blocks, while neighboring units disintegrate. And occasionally, several of those behaviors appear together. That is when professionals begin paying attention. Because finding one clue is interesting. Finding 4 clues occupying the same outcrop is something entirely different. And perhaps the most surprising aspect of all is that one of the strongest clues may not even belong to the rock itself. The reason experienced prospectors become suspicious when multiple patterns appear together is because mineralizing systems rarely leave behind only a single signature. They tend to disturb an entire neighborhood of rocks. Imagine 2 hillsides standing only a few hundred feet apart. Both are composed of similar lithologies. Both have experienced the same climate, the same rainfall, the same freeze-thaw cycles, and the same biological colonization. Yet one hillside appears strangely organized. Fractures seem denser, blocks weather differently. Small ledges persist where they should have disappeared long ago. The neighboring slope simply looks exhausted, reduced to loose rubble and soil. Most people would call that coincidence. Professionals occasionally call it a question worth asking. Because rock masses that once accommodated mineral-bearing fluids sometimes retain unusual physical behavior long after those fluids disappeared. Certain fractures become silicified and resist weathering. Adjacent zones become chemically weakened and collapse more readily. Tiny compartments begin forming between resistant structures, producing a subtle pattern that can be recognized from surprisingly long distances. And this is where many prospectors make an important mistake. They search for obvious veins, bright veins, thick veins, continuous veins. Experienced observers often become interested in the opposite. Interrupted structures, broken repetitions, discontinuous ribs, fragmented panels. Because hydrothermal systems are rarely polite enough to construct perfectly straight highways through the crust. They negotiate. They exploit weaknesses. They encounter resistant blocks. They reopen older fractures. They abandon pathways. They reactivate them later. The result can resemble a mosaic, not artistic. Geological. Imagine looking down at dry mud after a lake evaporates. Numerous angular shapes become separated by interconnected boundaries. Now imagine that pattern preserved in rock and later exposed by erosion. Suddenly, the outcrop no longer appears random. It appears compartmentalized. And compartmentalization occasionally matters. Because fluids carrying dissolved silica, sulfides, carbonates, and sometimes gold itself do not distribute uniformly. Some compartments receive repeated injections. Others remain largely untouched. Some become hardened. Others weaken. Some weather into protruding ribs. Others recess. Years later, prospectors arrive. Most see ordinary stone. Some begin counting repetitions, not consciously, instinctively. How many parallel structures? How many reopenings? How many changes in resistance? How many transitions occur within 20 feet? Because landscapes rarely repeat complex arrangements without reason. Then another clue appears. One that surprises many people. The vegetation, not because gold feeds plants. It doesn't. But altered ground occasionally changes drainage behavior. Moisture lingers differently. Fine material accumulates differently. Root systems encounter varying resistance. Certain shrubs colonize first, others struggle. The result is not dramatic enough to impress tourists. It may simply appear as an oddly shaped patch of vegetation occupying a narrow corridor through an otherwise uniform hillside. Most hikers photograph scenery. Prospectors occasionally photograph questions. Why is vegetation behaving differently there? Why does the fracture density suddenly increase? Why does weathering become selective? Why do some blocks ring sharply when tapped, while neighboring rocks crumble beneath pressure? And perhaps more importantly, why are all these observations occurring together? Because one clue can lie. Two clues can mislead. Four clues occupying the same small area become considerably more difficult to dismiss. Now imagine kneeling beside an outcrop and running your hand across its surface. One section feels smooth, another section feels granular. One side fractures cleanly, another side resembles compressed sugar. You may not be touching gold, you may not even be touching mineralization, but you might be touching the footprint left behind by an ancient plumbing system that once moved enormous volumes of fluid through the crust. And plumbing systems are interesting. Not because they guarantee discoveries, but because gold is notoriously reluctant to appear where pathways never existed. That realization changes how experienced prospectors walk. They stop walking toward glitter. They start walking toward architecture. toward repetition, toward disagreement, toward places where landscapes seem unable to behave normally. And surprisingly, one of the most persuasive examples of that abnormal behavior isn't found inside veins, fractures, or outcrops at all. It is found in the shape of the ground itself. Because sometimes an entire hillside quietly advertises a geological story that most people never learn how to read. And perhaps that's where many experienced prospectors begin separating themselves from everyone else, because they eventually stop searching for individual clues. They start searching for networks. A network simply means several independent observations occupying the same piece of ground and quietly supporting one another. One of the most persuasive examples begins with what professionals occasionally call a ladder pattern. Imagine standing 50 feet away from an outcrop. Across the face of the rock, narrow fractures appear almost parallel to one another. They may not be perfectly straight. Some bend, some terminate, some overlap. But collectively, they resemble the rungs of an old ladder leaning against a wall. Then another set of fractures intersects them, not randomly, consistently. The two directions repeat themselves throughout the outcrop. Suddenly, the rock mass becomes divided into numerous compartments. Weathering behaves differently inside each compartment. Some remain competent, others soften. Some protrude, others recess. And occasionally, these intersecting pathways once represented zones where fluids repeatedly negotiated access through the crust. Prospectors become interested because pathways matter. Gold rarely chooses isolation. Gold prefers opportunities. Opportunities are created by permeability. Permeability is frequently organized, and organization leaves patterns. Another network that occasionally attracts attention resembles fish scales. At first glance, the outcrop appears chaotic. Upon closer inspection, however, fractures overlap one another in a repeating shingle-like arrangement. Each fracture partially obscures another. Each opening appears to have formed under slightly changing stress conditions. To most observers, these simply appear to be broken rocks. To experienced geologists, they may represent repeated episodes of crustal adjustment, repeated openings, repeated fluid access, repeated opportunities for mineral deposition. Then comes perhaps the most overlooked arrangement, the zipper pattern. Imagine a narrow alteration corridor running through an otherwise resistant hillside. Along both sides of that corridor, small fractures branch outward at alternating angles. Left, right, left, right, almost resembling the teeth of a zipper. These structures occasionally develop because the crust rarely accommodates stress gracefully. Stress redistributes. New pathways appear. Old pathways reactivate. Mineralizing fluids exploit these weaknesses. Years later, erosion removes softer material. The architecture remains. And prospectors kneel down, not because they see gold, because they recognize a conversation preserved in stone. Perhaps the most visually persuasive network is what some field geologists informally describe as a spiderweb arrangement. A central structure occupies the middle. Numerous smaller fractures radiate outward. Secondary fractures intersect them. Weathering intensifies around intersections. Tiny recesses develop. Moisture lingers longer. Vegetation occasionally changes. Multiple clues begin agreeing with one another, and agreement is powerful because landscapes occasionally lie. Single clues occasionally disappoint. But when fracture organization, weathering behavior, slope morphology, moisture retention, vegetation response, and structural repetition begin occupying the same hillside, professionals become considerably more reluctant to dismiss the possibility that something important once occurred there. Now, does that mean every ladder pattern contains gold? Absolutely not. Does every spider web arrangement indicate mineralization?
What they pay
Certainly not.
per ton.
Nature enjoys imitation, but prospecting was never designed to guarantee discoveries. Prospecting was designed to improve probabilities, and probabilities improve dramatically when observers stop chasing isolated clues and begin reading networks. Because gold systems are surprisingly generous, they rarely leave only one fingerprint. They disturb rocks. They disturb chemistry, they disturb weathering, they disturb topography, and they occasionally disturb biological behavior as well. The challenge isn't forcing the landscape to reveal gold. The challenge is learning to recognize when the landscape can no longer completely hide its past. And perhaps that is the most valuable lesson hidden inside today's discussion. In our previous journeys, we followed gold after it escaped from host rocks. We learned that landscapes occasionally preserve nuggets in places gravity forgot. We discovered that ordinary terrain sometimes protects extraordinary stories. Today, we took another step backward through that journey. We learned that before gold ever becomes a nugget resting beneath someone's boots, before erosion liberates it, and before gravity negotiates its transport, the surrounding rocks often spend millions of years quietly recording the pathways that once fed the entire system. Most people continue searching for glitter. Experienced prospectors increasingly search for memory. Memory preserved in fractures, memory preserved in repetition, memory preserved in patterns. Because sometimes standing above hidden gold has very little to do with seeing the gold itself, and everything to do with recognizing that the rocks beneath your feet still remember where it once traveled, and perhaps the next outcrop you pass won't appear quite so ordinary anymore. Most people think finding gold is the hard part. Experienced prospectors know better, because discovering gold is only the beginning of the story. First, you must find the ground that hides it. Then, you must separate it from thousands of pounds of worthless rock and gravel. And finally, you must reveal the treasure that was hidden inside the dirt all along. This is the journey almost every gold documentary leaves untold. Not where gold formed, not where ancient rivers carried it, but what happens after you finally stand on productive ground and decide to recover it yourself. Because gold does not arrive ready. It arrives mixed with gravel, locked inside concentrates, hidden among black sands, buried beneath material that looks completely ordinary. And the remarkable part, the techniques that separate gold from everything around it are often far older than the machines people imagine. Some rely on gravity, some rely on patience. Some rely on understanding how gold behaves differently from every other material in the pan. The journey begins with mining, not giant excavators, not explosions, not mountains disappearing into crushers. Just one question: where should you dig? Because successful prospectors do not search for gold, they search for the dirt that carries it. Once that dirt is recovered, an entirely different challenge begins. Because a bucket full of promising gravel rarely looks valuable. Somewhere inside that bucket may be flakes, pickers, or even nuggets. But first, everything else must disappear. This is where milling begins. The slow process of reducing a mountain of material into a handful of concentrates. Reducing a shovel of gravel into a spoonful of black sand. Reducing possibility into evidence. And when that final concentrate finally settles in the pan, the last stage quietly arrives. Refining. The moment dirt becomes metal, the moment hidden color finally appears. The moment the countless hours of digging, washing, classifying, and concentrating finally answer a single question. Was the ground telling the truth? Because somewhere between the first shovel of dirt and the final gleam of gold in the pan, prospecting becomes something remarkable. Not mining, not treasure hunting, but a conversation with the landscape itself. And by the end of this journey, you will understand every step. How prospectors choose productive ground, how they reduce tons of material into a handful of concentrates, and how they finally reveal the gold that was hidden there all along. Because gold recovery isn't one skill, it's three separate stories. Mining, milling, and refining. and every nugget ever recovered had to survive all three. Unfortunately, the richest gold traps rarely sit in plain sight. They hide in places most people never think to check. Places where rivers keep secrets for decades, sometimes centuries. And the first of those secrets lies beneath your feet. False bedrock. Most beginners celebrate the moment their shovel hits hard material. They assume the search is over. Experienced prospectors become suspicious because not every hard layer is bedrock. Sometimes clay hardens like concrete. Sometimes compact gravel creates an almost solid floor. Sometimes ancient river sediments become cemented together so tightly that they feel like rock. Gold doesn't care what the layer is called. Gold only cares whether it can move deeper. If it can keep sinking, it will. That means stopping too early can leave the richest material untouched just a few inches below. Professional prospectors rarely trust the first hard layer they find. They test it, probe it, break it apart, ask one simple question. Can gold move through this? Because if the answer is yes, the search continues. Then another clue quietly appears. The pay streak. Most beginners imagine gold spread evenly across a riverbed. Nature almost never works that way. Gold travels in streaks, narrow ribbons, thin highways of heavy material running through otherwise worthless gravel. A prospector can dig 10 holes and find almost nothing, move 3 feet sideways. And suddenly every pan begins shining. This is why successful prospectors sample constantly, not because they enjoy digging, because they are mapping an invisible river inside the river, a river made not of water, but of weight. And somewhere inside that invisible channel, gold quietly waits. Then comes one of the oldest techniques in prospecting, crevicing. At first glance, it feels ridiculous. Digging inside cracks only a few centimeters wide, working with screwdrivers, brushes, small tools, almost like archaeology. Yet some of the richest recoveries in history have come from exactly these places, because gold behaves differently from gravel. When floods arrive, gravel moves, sand moves, even large stones sometimes move. Gold hesitates, then stops. The crack becomes its final address. Every flood adds another layer. Every season pushes more heavy material into the same trap. Some crevices quietly collect gold for generations, waiting for someone curious enough to look. Then another decision arrives. Dig or detect. Many beginners think detectors replaced traditional prospecting. Experienced prospectors know they simply answer different questions. The detector asks, "Is gold here?" The shovel asks, "How much?" One searches for nuggets, the other searches for pay dirt. Sometimes the detector wins. Sometimes the pan wins. The smartest prospectors learn to listen to both. Now another mystery. The river beside you may not even be the river that deposited the gold. Because rivers move. Over thousands of years, they abandon old channels and create new ones. What looks like an ordinary terrace above today's creek may once have been the bottom of an ancient river carrying enormous amounts of gold. These are bench gravels, old riverbeds stranded high above modern water. Most hikers walk past them without a second glance. Prospectors stop, because sometimes the richest ground in the valley sits nowhere near the present river at all. The old river moved away. The gold stayed behind. Then comes perhaps the hardest lesson in prospecting, knowing when to leave. This sounds simple. It isn't. A few colors in the pan create hope. Hope creates stubbornness. Stubbornness creates wasted days. Professionals trust samples more than optimism. If the gold disappears, they move. If the pay streak weakens, they move. If the evidence fades, they move. Because prospecting isn't about working harder than everyone else. It's about following evidence better than everyone else. Then one day, the evidence agrees. The black sands increase. The gravel changes. The bedrock improves. The pans become heavier. And suddenly, the river begins telling the same story over and over again. You're standing in the right place. This is the moment every prospector waits for, not the first nugget, not the first flake, the first confidence. The moment the landscape finally says, "Dig here." The shovel enters the ground. The buckets begin filling. Pay dirt slowly piles beside the river. Hours earlier, it looked like ordinary gravel. Now it feels different. Because somewhere inside those buckets, hidden among stones, sand, and black concentrates, the reason for all the searching may already be waiting. And perhaps that is the greatest surprise of all. Gold mining rarely begins with gold. It begins with observation, patience, questions, evidence. The shovel simply arrives at the end of the investigation because prospectors do not mine gold. Not yet. They mine possibility. And once the pay dirt finally leaves the riverbank, an entirely new challenge quietly begins. The gold may finally be captured inside the bucket, but it remains invisible, hidden among thousands of pieces of worthless material that look almost exactly the same. Finding the dirt was only the first battle. Now comes the second, separating treasure from everything trying to hide it. And that is where milling begins. Finding pay dirt is only the first battle. The real surprise begins after the bucket is full, because the gold may already be in your hands, but you still cannot see it. It is hiding under gravel, mixed with sand, buried inside black concentrates, protected by clay, covered by tiny particles that look completely worthless. This is where many beginners make their biggest mistake. They think recovery begins with panning. It does not. Recovery begins with preparation. Before one flake of gold can appear, the material must be broken down, washed, sorted, and reduced step by step until nature's hiding places disappear. This is milling. Not industrial milling, not chemical extraction, not dangerous refining. Just the safe, physical process of turning a bucket of raw gold-bearing material into a small amount of concentrate that can finally reveal what it contains. And the first rule is simple. Never try to recover gold from unsorted material. A bucket of pay dirt is chaos. Large rocks, pebbles, sand, clay, heavy minerals, organic debris, and somewhere inside it, a gold. If you put all of that directly into a pan, you're fighting the material instead of working with it. So the first step is classification. This means separating material by size. Large stones must leave first, then medium gravel, then smaller gravel, then sand. Why? Because gold hides better when different particle sizes are mixed together. Large rocks block water movement. Clay coats everything. Small gold can disappear beneath coarse gravel. A pan full of mixed material is difficult to read. But once everything is sorted by size, gold becomes easier to control. This is why experienced prospectors use screens. A simple classifier placed over a bucket can remove oversized rocks before the real washing begins. And here's the first important reward. Do not throw those large rocks away immediately. Check them first. Some may contain quartz. Some may be unusually heavy. Some may show visible gold. Some may be iron-rich. Some may be gold-bearing host material that broke away from the original source. A beginner throws away the big rocks. A careful prospector inspects them before discarding them. Once the oversized material is removed, the second step begins. Washing. Dry dirt lies. Wet dirt tells the truth. Clay can hide gold better than almost anything else in a bucket. It sticks to flakes. It coats black sand. It traps fine gold inside tiny balls of mud. If clay is not broken apart, gold can leave your pan still locked inside dirty material. So the material must be soaked. Water enters the bucket. The dirt is stirred. Clay breaks down. Gravel becomes clean. Sand separates. The entire bucket starts changing. What looked like worthless mud begins turning into readable material. This is the moment milling becomes real. You're not looking for gold yet. You're removing everything that prevents gold from being seen. After soaking, the next step is agitation. Not violent, controlled. The material is stirred, shaken, washed, and allowed to settle. This movement matters because gold is heavy. Every time the material is agitated in water, gold tries to move downward. Lighter material rises. Clay suspends. Organic debris floats. Gold sinks. That is the entire secret behind safe gold milling. You're not forcing gold to appear. You're allowing its weight to reveal itself. Now comes another important step. Decanting. After stirring, muddy water may rise to the top. That water carries clay and fine suspended material. Carefully pour off the dirty water while keeping the heavier material in the bottom. Then add clean water. Stir again. Let it settle. Pour again. Repeat until the water becomes clearer. Every repetition removes another layer of confusion. Clay disappears. Floating debris disappears. Light material begins leaving the system. The bucket becomes smaller, but better. This is one of the most satisfying parts of milling. You may begin with a heavy bucket of dirty gravel. After classification and washing, you may have only a fraction left, and that is exactly the goal. Gold recovery is not about keeping material. It is about removing everything that is not gold. Now the next stage begins, secondary classification. Once the material is clean, screen it again into smaller sizes. Coarse gravel goes one way. Fine sand goes another. Very fine material stays separate. This matters because coarse gold and fine gold behave differently. A picker can settle quickly. A tiny flake can float away if handled carelessly. A small nugget can hide beneath pebbles. Fine gold can ride on water tension if the pan is dirty or oily. So each size group deserves its own treatment. This is where beginners often lose gold. They rush. They pan everything together. They wash too aggressively. They dump material too quickly. Then they wonder why they recovered only a few colors. The gold was there. The process lost it. A careful prospector slows down here. Coarse material is checked first. Large, visible gold, pickers, or heavy fragments may be found quickly. Then the medium material is worked. Then the fine material. Each size tells a different story, and each one must be handled with patience. Now we reach the heart of milling. Concentration. This is where the remaining material is reduced even further using gravity. The goal is not to finish the gold. Not yet. The goal is to create concentrate. A concentrate is the heavy fraction left after most lighter material has been removed. It may contain black sand, magnetite, garnet, lead shot, tiny bits of iron, and hopefully, gold. The concentrate may look dark, dirty, and unimpressive. But this is where the treasure usually begins to show itself. A full bucket becomes half a bucket. Half a bucket becomes a pan becomes a cup becomes a spoonful, and inside that spoonful may be the entire reason the day mattered. This is why milling feels almost magical. You are not adding anything. You're only taking things away, and with every step removed, the gold becomes harder to hide. But there is one rule that must never be ignored. Keep your tailings, at least until you are sure. Tailings are the material you already processed and set aside. Beginners throw them away immediately. Experienced prospectors often keep them in a separate bucket until the final cleanup is complete. Why? Because mistakes happen. Gold can be lost during classification. Fine flakes can escape in muddy water. Small pieces can remain trapped in clay. If the first cleanup looks suspiciously poor, the tailings can be checked again. That one habit can save gold. The pay dirt has been classified, washed, cleaned, sorted, reduced. The useless material has begun disappearing. The heavy fraction is finally concentrated. But the gold is still not finished. It is sitting inside black sand, mixed with dense minerals, protected by heavies that refuse to leave easily. And this is where the next stage begins. Because milling does not end when you create concentrate. It ends when you learn how to separate the gold from the final material trying to hide it. At first glance, concentrate looks disappointing. Black sand, dark grains, heavy material, nothing that resembles treasure, nothing that resembles the reason you spent hours digging beside a river. Yet experienced prospectors know something important. This black material is not the enemy. It is evidence. Because black sand and gold share a secret. They obey many of the same physical rules. When water slows, black sand stops. Gold often stops beside it. When gravity separates material, black sand sinks. Gold sinks faster. Think of black sand as the crowd standing around the treasure. The crowd isn't the prize, but the prize is often somewhere nearby. Now begins the final reduction. The concentrate enters the pan. Not all at once, a small amount at a time. This is where patience becomes valuable. Too much material hides gold. Too little wastes time. The goal is balance. The pan enters the water. The material becomes submerged. Then comes the movement every prospector eventually learns. Gentle agitation. Not shaking, not washing. Stratification. This is the moment gravity quietly takes control. The heavier material works downward. The lighter material rises upward. Gold seeks the bottom. Black sand settles just above it. Lighter sands climb toward the surface. Nature begins sorting once again, not because the prospector forces it, because density never stops working. Once stratification is complete, the lighter material can begin leaving the pan. Slowly, carefully, small movements, small losses, small victories. This is where beginners become impatient. They become aggressive. The pan moves too quickly, the water flows too strongly, and somewhere inside the escaping sand, tiny flakes disappear forever. Experienced prospectors work differently. They assume gold is always trying to escape. So every movement becomes deliberate, every wash becomes smaller, every reduction becomes slower, because recovering gold and finding gold are often two different skills. Now another challenge appears. Black sand. Even after the lighter material disappears, the concentrate remains stubbornly heavy. Magnetite, hematite, dense minerals refusing to leave. Sometimes the pan looks almost black. The gold is there, but it hides beneath materials that behave very similarly. This is why many prospectors perform another reduction step. A magnet can remove some magnetic black sands, not the gold, only part of the crowd surrounding it. The concentrate becomes smaller, cleaner, more readable. And suddenly, the first flash appears, a tiny yellow reflection sitting quietly among the dark minerals, not moving, not floating, remaining exactly where gravity placed it. Gold. Perhaps only a flake, perhaps a picker, perhaps the beginning of something larger. This is the moment every prospector remembers, not because of the value, because of the confirmation. The river told the truth. The evidence was correct. The landscape kept its promise. Now comes another important lesson. Not all gold behaves the same. Coarse gold behaves confidently. It settles quickly. It remains visible. Fine gold behaves differently. It dances. It slides. Sometimes it appears to float. Surface tension can hold tiny particles surprisingly well. This is why water cleanliness matters. This is why gentle handling matters. Fine gold rewards patience. Coarse gold rewards observation. Both punish rushing. Then comes another discovery. The pan may contain more than gold. Lead shot, tiny pieces of brass, fragments of fishing weights, dense minerals, even old relics. Prospectors quickly learn that rivers are collectors. They preserve history as efficiently as they preserve gold. Every heavy object entering the system follows similar rules. The pan becomes a geological diary, a record of everything the river decided to keep. Now the concentrate becomes smaller still, a spoonful, perhaps less. Hours of digging reduced to almost nothing. At first glance, that seems disappointing. A full day of work becoming a few grams of heavy material. Experienced prospectors smile at this stage, because they understand something beginners do not. Gold recovery is a game of reduction, not accumulation. The goal was never to bring home more gravel. The goal was to remove everything that wasn't gold. And perhaps the most remarkable part of milling is this. The physics never change. A prospector in Alaska follows the same rules as a prospector in Arizona. A pan in California obeys the same laws as a pan in Australia. Gravity does not negotiate. Density does not change. Gold behaves like gold everywhere on Earth. The methods evolve. The equipment changes. The physics remain loyal. And eventually, the concentrate reaches its final form. The black sand is reduced. The heavies are separated. The gold becomes visible. Perhaps only a few flakes resting quietly in the corner of the pan. Perhaps several pickers. Perhaps a small nugget hiding among the concentrates. Whatever the result. The journey from dirt to gold is complete. But one final stage still remains. Because freshly recovered gold rarely looks like treasure. It arrives wet, dirty, sometimes coated with clay, sometimes attached to quartz, sometimes hidden among stains left by the ground that protected it for thousands of years. The gold is recovered, but it has not yet revealed its final face, and that is where refining begins. The gold has finally appeared. After the mining, after the digging, after the washing, after the milling, after the black sand slowly moved away, there it sits. A few flakes, a picker, maybe a small nugget, maybe a tiny pile of yellow pieces resting at the edge of the pan. But here is the part many beginners do not expect. Freshly recovered gold rarely looks finished. It does not always look like the bright treasure people imagine. Sometimes it arrives dull. Sometimes it is coated with clay. Sometimes it is trapped beside black sand. Sometimes it is attached to quartz. Sometimes it carries tiny stains from the ground that protected it for years. This is where refining begins. Not dangerous chemical refining, not industrial refining, not melting gold in unsafe conditions, but the safe prospector's refining process, the process of revealing what the gold already is. The first step is simple. Do not rush to clean it. That sounds strange. Most people want to make the gold shine immediately. Experienced prospectors slow down, because fresh gold can tell a story before it is cleaned. A rough nugget attached to quartz may be worth more as a specimen than as loose gold. A natural shape may interest collectors. A flattened piece may reveal transport history. A crystalline piece may carry more value because of its rarity. If you scrub everything too aggressively, you may remove details that made the piece special. So the first rule is observation. Look before cleaning. Separate the pieces by type. Fine flakes in one place, pickers in another, nuggets separately, quartz-attached specimens separately. This first separation matters because each type should be handled differently. Fine gold is delicate. Pickers are easier to control. Nuggets can be photographed and evaluated. Specimen gold must be treated with extra care. Now comes the first safe cleaning step. Clean water, nothing more. Place the recovered gold in a small clean container. Add water. Gently swirl. Let the lighter dirt loosen. Pour carefully. Repeat. This removes loose clay, sand, and mud without changing the natural surface of the gold. For many small placer finds, this is enough. The goal is not to make the gold look artificial. The goal is to reveal its natural color. Now another clue appears. If the gold still looks dull after rinsing, it may not be dirty. It may simply be natural. Real placer gold often carries tiny surface marks, transport scratches, rounded edges, small dents, natural stains. Those marks are not flaws. They are evidence. They show the journey from source rock to final trap. A prospector who understands this does not try to erase history. They preserve it. Now comes the second step. Remove obvious trash. Lead shot. Tiny bits of wire. Rust flakes. Brass fragments, fishing sinker pieces. All of these can appear in concentrates because rivers collect heavy objects. They settle for the same reason gold settles. But they are not gold. Use simple visual sorting. A small dish, a clean white background, good lighting, tweezers, patience. Pick out the obvious non-gold pieces one by one. This is slow, but it protects the gold. Beginners want speed. Professionals want certainty. Now comes another safe technique, the magnet check. A magnet can help remove magnetic black sand and small iron fragments from dry concentrates. But there is an important warning. Do not drag the magnet directly through the gold. Wrap the magnet in a plastic bag or hold it above the material so magnetic grains lift away without contaminating the magnet. This protects small flakes and prevents losing gold by accident. The magnet does not refine gold. It simply removes part of the material trying to hide it. Now the gold becomes more visible. The yellow stands out more clearly. The black sand decreases. The pan or dish begins looking cleaner. But the process is not finished. The next step is drying. Wet gold is hard to weigh accurately. Wet black sand sticks to everything. Tiny flakes cling to the sides of containers, so the material must be dried safely. Spread the cleaned material on a clean, non-porous surface. Keep it away from wind. Keep it away from dust. Keep it away from open drains or cracks where flakes can disappear. Let it dry naturally. Do not rush with unsafe heat. Do not blow air across fine gold. Fine flakes are easy to lose. Once dry, the gold can be sorted again. This is where the prospector finally begins to understand what was recovered. Very fine flour gold. Flat flakes, coarse flakes, pickers, small nuggets, specimen pieces. Each category tells a different story. Fine gold may suggest long transport or repeated grinding. Coarse gold may suggest a closer source. Angular pieces may not have traveled far. Rounded nuggets may have survived longer movement. Even at the refining stage, the gold continues teaching. Now comes weighing. Use a clean digital scale designed for small weights. Weigh gold only after it is dry and separate it from obvious non-gold material. Record the result, date, location, material type, recovery method, weight. This sounds simple, but it is one of the habits that separates serious prospectors from casual searchers. A single find is exciting. A record of many finds becomes knowledge. Over time, those notes reveal which locations produced better material, which gravel layer paid more, which trap held coarser gold, which recovery method worked best. This is why refining is not only about cleaning gold. It is about turning a discovery into information. Now comes another important decision. Should the gold be cleaned further? Sometimes yes, sometimes no. If the gold is only muddy, water cleaning is enough. If it is mixed with obvious black sand, careful mechanical separation may help. If it is attached to quartz or has an attractive natural shape, leave it alone. Specimen gold often gains value from its natural appearance. Collectors may prefer a nugget exactly as nature created it. Too much cleaning can reduce character. The prospector's job is not always to make gold look perfect. Sometimes the job is to protect what makes it unique. By the end of this first refining stage, the gold has changed. It is no longer hidden inside pay dirt. It is no longer trapped in black sand. It is no longer confused with trash. It has been rinsed, sorted, separated, dried, weighed, recorded. And now, for the first time, the recovery has become real. But one question still remains. What exactly do you have? Is it ordinary placer gold? Is it a specimen piece? Is it coarse gold from a nearby source? Is it fine gold carried far from its origin? Is it clean enough to store? Or should it be prepared differently for sale, collection, or future testing? That is where the final stage begins. Because finding gold is one thing. Revealing its true identity is another. At first glance, every piece of gold looks the same. Yellow, heavy, metallic, valuable. But experienced prospectors quickly learn something surprising. Not all gold is equal, not even close. Some gold spent thousands of years tumbling through rivers. Some traveled only a few hundred feet from the vein that created it. Some pieces still carry quartz attached to their surfaces. Others remain sharp and angular, as if they escaped their host rock only yesterday. The first task of refining is no longer cleaning. It is understanding, and understanding begins with shape. Look closely at the gold. Does it appear flat and smooth? That usually tells a story of distance. Long transport, countless collisions, years of rolling through gravel and stream beds, nature slowly polishing every edge away. But perhaps the gold appears rough, jagged, angular. Maybe small crystal faces still catch the light. That tells a very different story. This gold may not have traveled far at all. Its source could still be nearby, perhaps hidden somewhere upstream, perhaps still locked inside quartz, waiting for erosion to continue its work. Suddenly, the gold becomes more than treasure. It becomes evidence. Now another discovery appears. Color. Most people imagine gold as one color. Nature disagrees. Some gold appears deep yellow. Some looks pale. Some carries an orange tint. Some appears almost silver in certain light. Why? Because natural gold rarely exists alone. Silver often joins it. Sometimes copper joins it. The mixture changes the color. The appearance changes, even before testing. The gold begins revealing clues about its geological history. Then comes another important step. Storage. This sounds simple. It isn't. Gold is heavy. Fine gold behaves almost like dust. One careless movement, one gust of wind, one forgotten crack in a table, and a day's work disappears. Experienced prospectors become surprisingly protective at this stage. Small glass vials, secure containers, labels, dates, locations, weights. Every detail matters. Because memory fades, records remain. A single vial of gold becomes more than metal. It becomes a memory of a river, a mountain, a creek bend, a winter morning, a successful sample haul. Every vial tells its own story. Then comes another question every prospector eventually asks. Sell it or keep it? For many beginners, the answer feels obvious. Gold equals money, but experienced prospectors often hesitate. Because recovered gold has value beyond its weight. A nugget may carry collector value. A specimen with quartz may become far more valuable than its metal content alone. Crystalline gold may become irreplaceable. Some pieces are sold. Some pieces become family heirlooms. Some remain in display cases for decades. Not because they are valuable, but because of what they represent, the journey. Then another realization quietly arrives. The gold sitting on the table today once looked exactly like ordinary dirt, hours earlier. Nobody would have noticed it. Nobody would have stopped walking for it. Nobody would have imagined it was there. That transformation is perhaps the greatest reward in prospecting. Not wealth, recognition. The ability to see value before it becomes obvious. And perhaps that is the real meaning of refining. Not making gold valuable. Gold was already valuable. Refining simply removes everything that prevented you from seeing it. The gravel disappears. The clay disappears. The black sand disappears. Until eventually, only the truth remains. Gold. Now think back to the entire journey. First came mining, finding the right ground, reading rivers, studying bedrock, following clues. Then came milling, reducing buckets into concentrates, removing everything unnecessary, trusting gravity, trusting patience. And finally, refining, cleaning, sorting, understanding, revealing. 3 separate skills, 3 separate stories. Yet every piece of gold ever recovered by a prospector had to survive all 3. And perhaps that is why experienced prospectors rarely measure success only in ounces. Because long after the gold is weighed, long after the photographs are taken, long after the vials are stored away, the memory remains. The sound of gravel in the shovel, the first flash in the pan, the moment black sand moved aside. The realization that the river was telling the truth all along. That feeling cannot be bought, it cannot be manufactured, it has to be earned. And somewhere tonight, a river continues sorting gravel. A creek continues hiding black sand. A bedrock crack continues protecting a small piece of gold, waiting for another curious mind, another patient hand, another prospector willing to listen to the landscape long enough for it to answer back, because gold recovery never truly ends. The next discovery is always upstream. The gold has finally reached your hand. Not the river, not the pan, not the concentrate. Your hand, after millions of years beneath mountains, months of research, hours of digging, buckets of gravel, and countless movements of the pan. The journey has finally become personal. Now another question quietly arrives. How much is it worth? Most beginners answer immediately. The weight, the scale, the number. But experienced prospectors know something surprising. Gold has 2 prices. The first is the metal price. The second is the story. And those 2 numbers are often very different. Imagine placing a small natural nugget beside a perfectly smooth gold bar of identical weight. Same gold, same mass, same metal. Yet the nugget may sell for far more. Why? Because markets do not only buy gold. Sometimes they buy rarity, shape, beauty, history. Collectors pay for uniqueness, investors pay for purity, refiners pay for metal content. 3 buyers, 3 prices, 3 completely different worlds. This is the first lesson of marketing gold. Know who is buying, because the buyer determines the value. Now comes another surprise. The gold price shown on television is rarely the price a prospector receives. The number flashing across financial markets refers to highly refined investment gold traded internationally. Natural placer gold behaves differently. Collectors may pay more, dealers may pay less. Specimen pieces may command large premiums. Quartz specimens carrying visible gold can sometimes sell for several times their metal value, simply because another specimen exactly like it may never exist again. This is why experienced prospectors rarely rush to sell immediately. First they study, then they decide. Now let us talk about 2026. Because this year has reminded the world why gold has survived every financial system humans have ever built. During 2026, international gold prices climbed to some of the highest levels ever recorded before experiencing large swings as investors reacted to inflation, interest rates, and global uncertainty. Even after recent corrections, gold remains dramatically higher than it was only a year ago. Trading economics +1. At the time of writing, international spot prices are fluctuating around $4,000 per ounce, depending on market conditions and geopolitical events. Kitco +1. For perspective, only a few years ago, many people believed $4,000 per ounce was impossible. Now it is reality, and suddenly, the flakes sitting in a vial begin looking very different. The remarkable part is not simply the number, it is what created it. Central banks continue purchasing enormous amounts of gold reserves. Investors continue treating gold as financial insurance. Periods of inflation continue pushing attention back toward physical assets that cannot be printed or created overnight. World Gold Council +2 gold remains unique. A company can issue more shares. A government can print more currency. A mine cannot print another mountain. Nature controls the supply. Humanity only discovers it. That reality changes how many prospectors think about their finds. Some sell immediately. Some hold for years. Some build collections slowly, believing future prices may justify patience. Major financial institutions remain divided on exactly where gold will go next, but many continue forecasting elevated prices into late 2026 and beyond. JP Morgan Chase +2. Then comes another important question. Should a prospector sell flakes, pickers, nuggets, specimens? The answer depends on the market standing in front of you. Fine placer gold usually follows metal prices closely. Large nuggets often attract collector premiums. Visible gold in quartz enters an entirely different market, where rarity may matter more than weight. Sometimes the specimen becomes more valuable than the gold inside it, and that surprises many new prospectors. Because gold marketing is not simply selling metal. It is matching the gold to the right buyer. And perhaps that is where prospecting changes forever. The moment you stop asking, how much gold did I find? And start asking, what exactly did I find? Because ounces tell one story, the market often tells another, and somewhere between those two numbers, the real value begins to appear. The surprising truth is that recovering gold and valuing gold are completely different skills. Finding it requires geology. Recovering it requires patience. Selling it requires understanding people, because the market rewards some pieces far beyond their weight, while others quietly become worth less than their owners expected. And before any prospector decides to sell, there is one final question that changes everything. Who should you sell it to? And that is where our final chapter begins. Eventually, every prospector reaches the same crossroads, not at the river, not at the pan, not at the scale, but here, the moment they ask, do I sell it or do I keep it? Because for the first time in the journey, the gold stops being geology and starts becoming finance. The market does not care how cold the river was. It does not care how many buckets you dug. It does not care how many miles you walked. The market sees only three things: weight, purity, rarity. And each one speaks a different language. Weight speaks to refiners. Purity speaks to investors. Rarity speaks to collectors. A vial full of fine placer gold may follow the international gold price very closely. A large nugget may command a premium simply because large nuggets become rarer every year. A beautiful specimen with visible gold inside quartz may enter an entirely different world where collectors compete not for ounces, but for uniqueness. And suddenly, gold stops behaving like a commodity and starts behaving like art. Now comes the remarkable part. The world of 2026 has reminded investors why gold has survived every financial experiment humans have ever created. Gold reached historic highs earlier this year, breaking price levels many analysts once considered impossible before entering a period of sharp volatility and correction. Even after those fluctuations, gold remains one of the strongest performing major assets of recent years. Central banks continue buying enormous quantities of gold for their reserves, and many expect those purchases to continue throughout the coming years. World Gold Council too. Why? Because governments understand something prospectors learned long ago. Gold cannot be printed. Gold cannot be manufactured overnight. Gold cannot be created with a keyboard. The earth decides the supply. Humanity only discovers it. That reality has carried gold through wars, inflation, currencies, recessions, and generations of uncertainty. And perhaps that explains something every prospector eventually feels. The strange reluctance to sell, because after following gold through rivers, through black sands, through concentrates, through pans, through scales, the gold no longer feels like a product. It feels like a story, a memory, proof that the landscape spoke and someone listened. Perhaps that is why many prospectors keep their first nugget forever, not because it is worth thousands of dollars. Sometimes it isn't, but because it represents something much harder to buy: patience, persistence, curiosity, the willingness to believe that an ordinary piece of ground might still hide something extraordinary. And that may be the greatest lesson gold ever teaches. Because prospecting was never truly about becoming rich. It was about learning to see what others overlook, to recognize value before it becomes obvious, to trust evidence over assumptions, to follow clues rather than crowds. And somewhere tonight, a mountain continues weathering, a creek continues sorting gravel, a bedrock crack continues protecting a tiny piece of gold from the current above it, waiting for another storm, another season, another generation, waiting for someone willing to ask the same question prospectors have asked for centuries. What if there is still something hidden here? Because gold is not disappearing, the earth is still preparing it. The rivers are still moving it. The landscape is still hiding it. And the next discovery may already be waiting beneath someone else's footsteps, or perhaps beneath your own. From hidden ground, to paid dirt, to concentrates, to gold, to markets. The journey is complete, but somewhere beneath the mountains, the earth has already begun writing the next story. Imagine standing on top of a mountain that has never been mined. No abandoned tunnels, no rusted equipment, no old prospectors' camps, nothing except endless ridges, weathered rocks and valleys stretching toward the horizon. To most people, every hillside looks exactly the same. But an experienced exploration geologist can often point toward one narrow valley and quietly say, "That's where I would begin looking for gold." Not because they can see the gold, not because they own expensive equipment, but because they can read something almost invisible: the geological map. Not the folded paper maps carried in backpacks, the one written directly into the landscape itself. Every mountain, every fault, every broken ridge, every color change, every quartz vein, every stream, every hillside. Together, they form a geological story that has been unfolding for hundreds of millions of years. And once you learn to read that story, the ground begins revealing where gold is most likely to hide. The remarkable part: nature has already drawn the map. Our job is simply learning how to read it. So where do professionals begin? Not with gold, with boundaries. Because every geological map begins where one rock suddenly becomes another. Walk across almost any mountain range and you'll eventually notice something unusual. Dark volcanic rocks suddenly disappear. Pale granites begin appearing. Schists gradually become quartzites. The landscape quietly changes beneath your feet. Most hikers never notice. Geologists stop immediately because these boundaries are called geological contacts. They are more than lines separating different rocks. They are ancient zones of weakness. During mountain building, these contacts often became pathways where hot mineral-rich fluids moved through the crust. Those fluids carried silica, iron, sulfur, copper, and sometimes gold. That doesn't mean every geological contact contains gold. Far from it. But history has shown that many important gold systems developed close to these ancient boundaries because fluids naturally preferred traveling through existing weaknesses rather than forcing entirely new pathways. Now here's the first professional field technique. Imagine you've located a contact between two different rock types. Don't search randomly across both hillsides. Instead, follow the contact itself. Walk along it. Watch how the rocks change. Notice where quartz veins begin appearing. Look for rusty staining. Search for broken float rocks scattered downhill. If erosion released gold from that contact millions of years ago, gravity rarely carried the heaviest nuggets very far. Many remained surprisingly close to their original source. One geological clue, one practical search strategy. Already the map begins making sense, but perhaps the contact suddenly disappears beneath loose soil. Has the trail ended? Not at all. Another clue immediately appears. Broken ground. From a distance, it looks like destruction. Collapsed ridges, angular boulders, fractured outcrops, loose blocks scattered across the slope. Most people avoid these places because walking becomes difficult. Experienced prospectors often slow down because rocks rarely break without a reason. Deep beneath the surface, enormous tectonic forces compressed, stretched, and twisted the Earth's crust. Some rocks resisted, others shattered. Those shattered zones became highways, not for people, for mineral-rich fluids. Imagine pouring water across smooth concrete. It spreads in every direction. Now imagine pouring that same water across cracked pavement. Immediately it follows the fractures. Hydrothermal fluids behaved in much the same way. Whenever the Earth fractured, hot fluids carrying dissolved minerals exploited those openings. As temperatures slowly cooled, minerals crystallized inside the cracks. Quartz formed, sulfides formed, and in favorable conditions. Gold crystallized with them. Today, millions of years later, erosion has stripped away enormous amounts of rock. What remains are the broken remnants of that ancient plumbing system. Now comes another professional technique. Don't begin detecting the middle of a shattered hillside. Instead, find the most intensely fractured outcrop, then slowly work downhill until the slope begins flattening. Gravity naturally slows that. Heavy fragments released from weathering often accumulate near the first gentle break in slope. If coarse gold was released from those fractures, many nuggets never traveled much farther. Again, the geological map quietly points the way. Now another discovery appears. Quartz. Most prospectors become excited the moment they see a white quartz vein. Professionals ask a different question. Is it alone, or is it connected? One isolated quartz vein rarely tells the entire story. Networks do. Look carefully. Does one vein split into three? Do several veins intersect? Do thin stringers branch away into surrounding rock? Those branching patterns often reveal repeated pulses of mineral-rich fluids entering the same structural zone over immense periods of time. More fluid movement often meant more opportunity for gold deposition. Notice something remarkable. Nature rarely wastes energy. Once a pathway successfully transported hot fluids, later fluids frequently reused exactly the same corridor. The result is a network rather than a single vein, and that network becomes another piece of the invisible geological map. Now here's another field technique. Forget chasing every quartz vein you see. Instead, search where several veins meet. Walk downslope from those intersections. Inspect weathered float quartz lying below. If quartz fragments become increasingly abundant, while iron-rich rocks also begin appearing, your geological evidence is becoming stronger. One clue supports another supports the next, until eventually the landscape begins agreeing with itself. And when geology begins agreeing, professionals start paying very close attention. Notice something interesting. Quartz suddenly disappears. At first, that seems disappointing. Many beginners assume the geological story has ended. Professionals often become even more curious. Because the map rarely ends where the quartz ends. Sometimes the fluids simply changed direction. Sometimes another structure quietly took over. And that brings us to one of the most overlooked clues in gold exploration. Ion alteration. Walk across a fresh hillside, and you may notice ordinary gray rocks. Walk another 50 yards, and those same rocks suddenly become stained with rusty reds, oranges, and dark browns. Most people think they're simply looking at rust. They're seeing something much older. Millions of years ago, hot hydrothermal fluids didn't only carry gold. They also carried iron-bearing minerals. As oxygen and groundwater slowly attacked those minerals near the surface, they transformed into iron oxides, leaving behind the rusty colors we see today. Those colors are not gold, but they often remember where the fluids once traveled. Now comes another professional technique. Don't search the brightest red rock you can find. Instead, walk around the entire alteration zone. Notice where the rusty staining becomes strongest. Then ask another question. Is broken ground nearby? Are quartz veins crossing the same area? Are dark iron stones scattered downhill? When several clues occupy the same small area, you've just increased your chances far more than wandering across an entire mountain. One observation becomes another. Another becomes confidence, and confidence saves time. Now another clue quietly appears. Look at the shape of the mountain itself. Most people admire the summit. Professionals study the folds. Not every mountain rises in a straight line. Some gently curve, others bend like enormous waves frozen in stone. These are geological folds. They formed when continents collided under unimaginable pressure. As those rocks bent instead of breaking, something remarkable happened. Pressure concentrated near the fold hinges. Tiny fractures multiplied. Old fractures reopened. New pathways developed. Hot fluids quickly discovered those weaknesses. And once again, the invisible geological map quietly expanded. Now here's another field technique. If you recognize a folded ridge, don't spend your entire day searching both sides equally. Begin near the hinge where the rocks curve most sharply. Inspect nearby quartz veins. Look for iron alteration. Search downslope where erosion has released weathered material from that compressed zone. Some of the world's richest gold districts owe their existence to exactly these folded structures. Now, another reward. The map isn't only written in rocks, it's written in erosion. Stand halfway down a hillside. Look carefully. Do you notice loose quartz fragments becoming larger as you climb? Do iron stones suddenly become more abundant? Does the gravel become noticeably coarser? Those aren't random changes. They point uphill. Nature is quietly telling you where the original source may still be hiding. Professionals call these float trains. Loose fragments slowly migrating downhill after thousands of years of weathering. Each season, gravity moves them a little farther, but dense material rarely travels as quickly as lighter debris. That means the source often remains surprisingly close. Now comes another practical technique. Instead of detecting every square meter of the hillside, follow the float. Walk uphill. Watch where the fragments become larger. Watch where they become more numerous. Eventually, they begin disappearing. That disappearance matters, because somewhere just above it, the original structure may still remain inside solid bedrock. Now another clue appears where almost nobody thinks to look. The small gullies cutting across the slope, most prospectors hurry past them because they appear insignificant. Professionals inspect them carefully. Every heavy rainfall quietly cleans those miniature drainages. Loose soil disappears. Fresh bedrock becomes exposed. Heavy minerals begin collecting inside tiny cracks. Sometimes the gully is only a few feet wide. Yet it has already completed years of natural sampling for you. Nature has gathered material from the entire hillside and concentrated it into one narrow channel. Another reward, another shortcut, another page of the geological map. Now imagine stepping back and looking across the entire mountain. Suddenly, everything begins connecting. The geological contact, the broken ground, the quartz network, the rusty alteration, the folded ridge, the downhill float, the small gullies. Individually, each clue tells only part of the story. Together, they point toward exactly the same place, and perhaps that is the greatest discovery of all. Professional geologists rarely search for gold. They search for agreement, because when geology begins repeating the same message through different clues, the invisible map becomes visible. And that is often where the real search for gold nuggets finally begins. Most people become excited the moment they discover a white quartz vein crossing a hillside. Experienced geologists become curious for a completely different reason. Not every quartz vein carries gold. In fact, most never will. Yet throughout history, some of the world's richest gold discoveries have begun beside a single white streak cutting across an ordinary mountain. At first, that seems impossible. How can two quartz veins standing only a few feet apart tell completely different stories? One remains nothing more than ordinary stone. The other becomes part of a gold deposit worth millions. The answer isn't the color. It isn't the size, and it certainly isn't luck. The answer is hidden inside the way the quartz was built. Every quartz vein records a geological event. Some record only one pulse of mineral-rich fluid. Others record dozens. Every crack, every crystal, every tiny layer growing inside that fracture quietly preserves another chapter of the Earth's history. And if you learn to read those chapters, the rock begins revealing where gold was most likely to stop its journey. Imagine standing beside a freshly exposed quartz vein. Forget the gold for a moment. Look at the quartz itself. Does it appear perfectly solid from one edge to the other? Or does it contain countless tiny fractures crossing in every direction? That question matters far more than most prospectors realize. Quartz rarely forms all at once. Instead, the Earth builds it in stages. A fracture opens, hot mineral-rich fluid rushes upward. Quartz begins crystallizing against the walls. Before the fracture completely seals, the Earth moves again. The vein cracks open once more. Another pulse arrives. More quartz grows. Then the cycle repeats. Again. And again. Each reopening creates another opportunity. Not only for quartz, but eventually for gold. Now here's the first professional nugget finding technique. Don't judge a quartz vein from a distance. Walk directly to it. Study the fracture density. If the quartz appears heavily broken, with numerous healed cracks crossing the vein, you're looking at evidence that the Earth's plumbing system remained active through multiple geological events. Multiple fluid events often create more opportunities for gold than a single pulse ever could. Already, the landscape has given you your first clue. Now another discovery appears. Look closely at the crystals. Not all quartz cools the same way. Some veins contain large, glassy crystals that grew slowly over long periods. Others contain millions of tiny crystals packed together like coarse sugar. To many hikers, they're simply different kinds of quartz. To a geologist, they're records of changing temperatures. Rapid cooling often leaves behind fine crystalline textures. Slower cooling builds larger crystal faces. Neither guarantees gold, but both tell you how the hydrothermal system behaved while the vein was forming. And understanding the system is far more valuable than guessing. Now another reward. Instead of searching the entire vein, find the place where the crystal texture suddenly changes, where coarse crystals become fine, where massive quartz becomes fractured, where one growth stage meets another. Those transitions often record changing pressure conditions, exactly the moments when dissolved minerals began behaving differently. Sometimes, those are also the places where gold quietly entered the system. Now another clue begins revealing itself. Notice how the vein moves through the host rock. Does it continue in one straight line for hundreds of feet? Or does it suddenly split into two, then three, then several smaller branches? That branching pattern deserves attention, because hydrothermal fluids rarely traveled randomly. Whenever pressure increased inside the fracture, the fluid searched for new escape routes.
I'll be darned. Okay.
Small branches developed.
Oh boy, you
New
guys can't
openings
see it.
formed. The plumbing system expanded. Every new branch became another opportunity for mineral-rich fluids to circulate. Now comes another practical technique. Don't stop at the widest section of the quartz vein. Walk toward the branching zone. Inspect every smaller offshoot. Many prospectors unknowingly spend hours detecting the obvious vein while completely ignoring the network surrounding it. Yet those smaller branches often record repeated fluid movement through the rock. Sometimes,
you make a fresh break.
The most interesting discoveries begin where the largest vein quietly gives way to dozens of smaller ones. And perhaps that's the first secret quartz has been trying to tell us all along. It isn't simply the presence of quartz that matters. It's the history preserved inside it. Every fracture, every crystal, every branch, every reopening, every layer. Together they form a geological diary, waiting for someone who knows how to read the next page. But perhaps the greatest mistake prospectors make isn't walking past a quartz vein. It's leaving too early. The moment many people fail to find visible gold inside the quartz, they simply move on. Experienced prospectors often do exactly the opposite. Because the quartz vein itself may not be the final destination. It may only be the beginning of the journey. Imagine standing beside a large white quartz vein cutting across a mountainside. For thousands of years, rain has fallen on that ridge. Winter ice has forced tiny fractures farther apart. Summer heat has expanded the rock. Gravity has slowly pulled against every weakened surface. Little by little, the vein begins breaking apart. Not all at once. One fragment today, another next year, thousands more over millions of years. Eventually, pieces of quartz begin rolling downhill. Some are no larger than a coin. Others are the size of a backpack. At first, they seem scattered randomly. They aren't. Gravity is surprisingly organized. The heaviest fragments rarely travel the farthest. The largest blocks usually remain closest to the original vein. Smaller pieces continue farther. This creates something experienced geologists immediately recognize. A float train, not a railway, a geological trail, a natural line of broken quartz leading back toward its source. And perhaps this is one of nature's simplest treasure maps. Now comes another professional technique. Don't begin searching at the largest quartz block you find. Walk uphill. Notice whether the fragments become larger. Notice whether they become more numerous. If the answer is yes, you're probably moving closer to the original vein that released them. Nature has already drawn an arrow. You simply need to follow it. But another discovery quietly appears. Not all broken quartz looks the same. Some fragments are rounded. Others are sharp enough to cut your hand. That difference tells another story. Rounded quartz has usually traveled much farther, colliding with other rocks until its sharp edges disappeared. Angular quartz often broke away much more recently. That means the original source may still be nearby. Professionals become excited when they find fresh angular quartz scattered across a hillside, because fresh breakage often means fresh exposure. And fresh exposure sometimes reveals mineralized structures that remained hidden for thousands of years. Now, another clue. Watch the width of the vein itself. Many quartz veins behave strangely. They become narrow, then suddenly widen, then narrow again. Geologists call this pinch and swell. To most hikers, it looks like an irregular crack. To an exploration geologist, it records changing pressure deep beneath the earth. Where fractures suddenly widened, larger volumes of hydrothermal fluid could circulate. More fluid meant more mineral deposition. More mineral deposition sometimes meant better conditions for gold. Now another field technique. Don't spend equal time along the entire vein. Instead, inspect the swell zones first. Look where the vein suddenly becomes thicker. Study the surrounding broken quartz. Watch for small branching veins leaving the main structure. Those wider sections often experience the most intense fluid movement. Sometimes they also became the richest parts of the system. But perhaps the most exciting moment comes much later, long after the quartz has broken apart, long after the mountain has weathered, long after streams begin carrying fragments downhill. Quartz and gold finally separate. The quartz continues breaking. Gold doesn't. Quartz becomes smaller. Gold simply becomes free. Because gold is far denser than quartz, their journeys immediately become different. Quartz fragments continue tumbling downstream. Gold quickly begins slowing down. It settles into cracks, tiny bedrock depressions, natural shelves, behind resistant rocks, inside narrow fractures invisible beneath flowing water. That is why many placer nuggets owe their existence to quartz veins that may now be completely gone. The original vein disappeared millions of years ago. The gold remained, waiting. Now another practical technique. If you discover abundant broken quartz scattered across a slope, don't stop there. Follow the drainage immediately below. Inspect exposed bedrock. Look for natural cracks running across the flow. Search behind large, stable boulders. Nature often completes the final stage of concentration for you. The hillside releases the gold. Gravity transports it. The stream quietly stores it. Now think back to everything we've discovered. The Earth's crust fractures. Quartz fills those fractures. The vein reopens. Quartz grows again. Gold finally crystallizes. Weathering breaks the vein apart. Gravity moves the fragments. Streams sort the heavy minerals. Bedrock captures the survivors. Every nugget follows this remarkable journey. Not in days, not in centuries, but over millions of years. Have you ever driven past a hillside that looked completely worthless and never realized it may have been carrying the fingerprints of gold the entire time? No abandoned mine, no glittering quartz vein, no prospector standing beside a creek. Just another hill, another slope, another stretch of forgotten ground somewhere in the American West. And yet some of the richest gold systems ever discovered in the United States began exactly that way. Not with a nugget, not with a detector signal, but with a hill nobody paid attention to. Across Nevada, Arizona, California, Alaska, Colorado, even in places where most people would never think to look. The strange part is that gold itself is rarely the first thing to appear. The hill speaks long before the gold does. The question is, can you recognize what it's saying? The first clue isn't gold, it's discomfort. Experienced geologists often describe certain landscapes the same way. Not beautiful, not rich, not promising. Just unusual. A hill that feels different from everything surrounding it. A slope where the colors suddenly change. A ridge where the rocks appear fractured for no obvious reason. A drainage system behaving differently than neighboring valleys. Most people ignore those details. Geologists don't, because nature rarely creates anomalies without a cause, and hidden gold systems are masters of creating anomalies. Millions of years ago, before these hills ever existed, something else was happening beneath them. The Earth's crust was under pressure. Fractures were opening. Superheated fluids were rising upward through fault systems carrying dissolved minerals from deep underground. Those fluids weren't carrying gold alone. They carried iron, silica, sulfur, trace metals, entire chemical cocktails moving through rock under conditions almost impossible to imagine today. As those fluids cooled, the chemistry changed. Minerals precipitated, structures formed. And somewhere within that process, gold began concentrating. Not randomly, systematically, following pathways invisible to the human eye. The problem is that most of the original gold system often remains hidden. What reaches the surface first are the scars, the chemical fingerprints, the damage left behind. And that's exactly what these hills are showing us. Look at an ordinary hillside from a distance. What do you see? Most people answer, dirt, rock, vegetation, shadows. But geologists see something entirely different. They see chemistry, they see oxidation, they see fluid movement frozen in time, they see a geological crime scene that happened millions of years ago, and sometimes the evidence is hiding in plain sight. Take color, for example, not bright colors, subtle ones. A rusty stain running across an otherwise pale hillside. A strange bleach-white patch cutting through darker terrain. An isolated red ridge surrounded by normal soil. These color changes aren't decoration. They're evidence. Evidence that the ground experienced something unusual. Something powerful enough to alter the rock itself. Now here's where things become fascinating. The most valuable hills often don't look valuable at all. In fact, some of the strongest mineralized systems in the American West appear strangely dead, pale, washed out, almost lifeless. That's because certain hydrothermal fluids actually destroy the original minerals in the host rock. The rock becomes chemically altered, its original identity erased. To casual observers, it looks barren. To trained eyes, it looks disturbed. And disturbed ground deserves attention, because nature rarely disturbs itself without reason. Now imagine standing in Nevada. The desert stretches for miles. Everything looks similar. Brown hills, dry washes, scattered sagebrush. Nothing dramatic. Then suddenly you notice one ridge. Not because it's larger, not because it's beautiful, because it doesn't belong. Its coloration is wrong, its texture is wrong, its weathering pattern is wrong. Something happened there. And once that thought enters your mind, the investigation begins. This is where many discoveries start, not with certainty, with suspicion. One strange observation, one unanswered question, one hill refusing to behave like the others. Now let me ask you something. If gold itself remains hidden underground, how would you know you're close? That's the puzzle prospectors have been solving for generations. And the answer has never been simple, because gold rarely advertises itself directly. Instead, it alters its surroundings. Think about that carefully. The gold may remain invisible, but the system that created it leaves clues everywhere. Those clues become the language of the landscape, and once you learn that language, entire regions begin feeling different. The American West is filled with hills like this, thousands of them, most ignored, some famous, a few life-changing. And here's the unsettling part. Many major discoveries happened in places people had already walked across countless times. The clues were there. The understanding wasn't. One of the most overlooked clues is structure, not color, not quartz. Structure. Look at how a hill breaks apart. Look at how fractures move through it. Look at how drainage systems cut across it. These details matter because gold-bearing fluids require movement. They need pathways, faults, fractures, weak zones in the crust. Without those pathways, the fluids never reach the right places. Without the fluids, the system never forms. And suddenly, that ordinary hillside becomes something much more interesting. It becomes evidence of movement. Ancient movement. Violet movement.
Excellent.
The kind that reshapes entire geological systems.
And there you have it, folks.
Now here's where things become dangerous for the casual observer. Once you start seeing these clues, you begin finding them everywhere. A rust-colored cut beside a highway. A bleached slope hidden above a creek. An unusual ridge exposed after erosion. The landscape starts speaking. And that's exactly why experienced prospectors move differently through terrain. They're not searching for gold. They're searching for contradictions, things that shouldn't be there, patterns that don't fit, evidence that something unusual happened beneath the surface. Because hidden gold systems create contradictions constantly. Now imagine a hillside shedding broken quartz downhill year after year. Not giant veins, just fragments, scattered pieces, weathered shards mixed into the soil. On their own, they mean very little. But then you notice iron staining nearby, then altered rock, then fractured bedrock. One clue becomes two, two become three, and suddenly the probability changes. That's how serious prospecting works, not through luck. Through accumulation of evidence, the hill slowly builds a case. Now here's something most people never consider. Some hills produce gold-bearing sediment for thousands of years without ever revealing their true source. Think about that. A creek may carry gold generation after generation. Prospectors find flakes. Nuggets appear occasionally. Yet the original system remains hidden. Why? Because erosion is slow. The landscape reveals itself gradually. The earth is patient, far more patient than we are, and that's why certain hills become legendary. Not because they reveal everything, because they reveal just enough to keep people searching. Now let's talk about another clue. Weight. Not visible weight. Geological weight. Certain hills produce heavier sediments than others. Black sands, dense gravels, iron-rich concentrates. These materials don't accumulate randomly. They're responding to the same forces influencing gold movement. Gravity becomes the great sorter. Over time, the landscape begins separating materials according to density. The lighter particles travel farther. The heavier particles stay behind, and gold belongs firmly in the heavy category. Which means whenever you find evidence of heavy mineral concentration, the question naturally follows. What else may have settled here? That's how curiosity grows inside geological investigations. Every answer creates another question, and the best hills never stop asking questions. Now here's a fascinating observation. Many gold-bearing hills don't reveal their secrets through the hill itself. They reveal them through the terrain below, the creek, the wash, the drainage, the sediment. The hill acts like a source. The landscape becomes the messenger. That's why experienced prospectors study entire systems rather than isolated locations. The hill, the water, the structure, the chemistry, everything connects. And when enough pieces align, the ordinary suddenly becomes suspicious. The hill keeps its secrets, just enough to stay interesting, not enough to surrender completely. Now let's go deeper. What if the hill isn't the destination? What if it's only the outer edge of something larger? This possibility changes everything. Many major gold systems exist as parts of enormous geological networks. The visible clues represent only fragments of the whole structure, like seeing smoke without seeing the fire. And somewhere out there tonight, across the deserts, mountains, and forgotten drainages of the American West, another one of those hills is still waiting, not revealing, not surrendering, just leaving clues, quietly, patiently, the same way it has for millions of years. And the strangest part, the gold may not even be the biggest secret hidden there, because in our next investigation, we're going beyond the hills themselves. We're going to examine why gold keeps appearing in the same places over and over again, even when the landscape changes completely. Because the hills are only the beginning. The system beneath them is where the real mystery starts. Have you ever noticed something strange about gold discoveries? Entire mountain ranges exist across America. Millions of rivers flow through them. Countless hills erode every year. And yet, gold has an unusual habit. It keeps showing up in the same places, the same drainages, the same bends in rivers, the same valleys, the same mountain belts, again and again and again. At first, that seems obvious. Of course, gold would appear where gold already exists. But that's not the mystery. The mystery is why nature repeatedly concentrates gold into specific locations while ignoring thousands of others that look almost identical. Because if gold simply scattered randomly through the landscape, prospectors would never have built entire mining districts. There would be no famous gold regions, no legendary creeks, no valleys producing gold generation after generation. Instead, the earth behaves with a strange consistency, almost as if an invisible set of rules is guiding gold toward the same destinations. And today, we're following those rules. Because the hill we investigated previously may have revealed something far more important than hidden gold. It may have exposed the system itself. The first mistake people make when thinking about gold is imagining that gold moves like ordinary sediment. It doesn't. Gold behaves differently, much differently. A grain of quartz and a grain of gold may sit beside each other in a stream. The water touches both. The current pushes both. The flood carries both. Yet their journeys are completely different because gold is extraordinarily dense, nearly 19 times heavier than water. That single fact changes everything. Imagine a violent storm moving through the mountains. Rain falls for hours. Small streams become rivers. Rivers become torrents. Entire hillsides begin collapsing into the valleys below. The landscape enters motion. To us, it looks chaotic. But hydraulically, something remarkable is happening. The flood is sorting. Every particle in the system is being tested. Light materials travel farther. Heavy materials resist movement, and among those heavy materials, gold becomes one of the most stubborn substances in the entire landscape. That's why gold doesn't simply travel. It negotiates every inch of its journey. Every flood must earn the right to move it. Every current must overcome its weight. Every river bend must decide whether to carry it or keep it. And eventually, the river loses the argument. The gold stays. Now, here's where the investigation becomes interesting. If gold settles wherever energy collapses, why do certain places repeatedly collect it? Why not everywhere? The answer begins with something hidden beneath nearly every successful gold district in America. Geometry. Not visible geometry, hydraulic geometry. The shape of the landscape itself. Look at any famous placer gold region: California, Alaska, Colorado, Arizona, Montana, Nevada. Different climates, different elevations, different histories. Yet the same pattern appears repeatedly. The terrain creates traps, not obvious traps. Invisible traps, a narrowing valley, a buried bedrock ridge, a sharp inside bend in an ancient river, a fracture hidden beneath gravel, a depression carved into hard rock millions of years ago. These features change the behavior of water. And when water changes, gold responds. Imagine a river carrying thousands of tons of sediment during a flood. The current races downstream, everything moves, then suddenly the river widens. Energy drops, velocity collapses, and the sorting begins. The lighter material continues. The heavier material hesitates. Gold hesitates more than anything else. That hesitation becomes concentration, and concentration becomes a deposit. Now imagine this process repeating for 10,000 years. One flood, then another, then another. Every event delivering new material, every event testing the landscape, and every event dropping gold into the same hydraulic traps. The result is extraordinary. Nature begins building deposits, not in years, not in centuries, but across geological time. This is why some rivers seem almost magical. Prospectors return generation after generation. Gold continues appearing, the landscape keeps producing, and the reason isn't luck. The trap never stopped working. Now let's go deeper, because rivers are only half the story. The second half exists underground. Think back to the hill from our previous investigation. The altered rock, the fractures, the strange coloration, the evidence that mineralized fluids once moved through the earth. That hill wasn't just producing gold, it was feeding a system. And systems create repetition. Imagine a mountain slowly eroding, year after year, storm after storm, century after century. Tiny fragments enter nearby streams. Some contain gold, most do not. But the gold-bearing fragments keep arriving. the source keeps feeding the landscape, and downstream, the same hydraulic traps keep collecting the material. Suddenly, the mystery changes. We're no longer asking, why is there gold here? We're asking, how long has this process been operating? Because some of these systems have been functioning for millions of years. Millions. Think about that. Entire civilizations rise and disappear in a fraction of that time. Yet the Earth quietly continues concentrating gold. One flood at a time, one storm at a time, one erosion cycle at a time. Now here's the strange part. Sometimes the original source disappears completely. The mountain erodes away, the exposed vein vanishes, the hill changes shape, the evidence fades, yet the placer deposit remains. Gold continues appearing downstream even though the source that created it may no longer exist in recognizable form. To prospectors, this creates a puzzle. A creek produces gold, the source cannot be found. Searches fail, generations pass, and still the creek produces. It's almost like chasing a ghost. But geology rarely creates ghosts, only clues. And those clues often point toward older landscapes hidden beneath the modern one. Ancient rivers, buried channels, forgotten drainage systems, worlds that existed long before the present terrain. This is where the investigation becomes truly fascinating. Because gold doesn't just collect in places, it remembers places. Ancient floodplains, abandoned riverbends, long buried channels. The modern landscape may look completely different, but the gold still follows the architecture of the past. In some parts of the American West, prospectors discovered gold-rich channels buried hundreds of feet beneath modern ground. The original rivers vanished millions of years ago. The terrain transformed. Mountains rose. Volcanoes erupted. Valleys shifted. Yet the gold remained exactly where hydraulic physics left it. Waiting. Preserved. Silent. This changes the entire way we think about gold districts. They're not isolated discoveries. They're memories. Records of ancient systems still influencing the present. Now let me ask you something. What if the richest gold locations aren't rich because they contain more gold? What if they're rich because the landscape is better at collecting it? That possibility changes everything. Because suddenly the focus shifts away from the gold itself and toward the machine that concentrates it. The earth becomes the miner. The rivers become the sorting system. Gravity becomes the processing plant. And time becomes the workforce. Gold is simply the final product. That realization explains something prospectors have observed for centuries. And somewhere within that process lies the answer to a much larger question. If gold keeps collecting in the same places, what determines where those places exist in the first place? Because that's where our investigation leads next. Not to the rivers, not to the deposits, but to the hidden structures beneath them. The ancient forces that decided where the gold system would begin long before the first river ever flowed. And once you see those structures, the hills, rivers, and deposits we've investigated so far begin fitting together like pieces of a much larger puzzle. Because gold doesn't simply collect in the same places. The earth keeps directing it there, and that may be the biggest clue we've uncovered so far. Have you noticed something strange? For decades, people have been told that the great gold rushes are over, that the easy gold is gone, that the mountains have already been searched, the rivers already worked, the discoveries already made. And on the surface, that sounds reasonable. After all, the famous rushes happened more than a century ago. Millions of ounces were recovered. Entire towns appeared and disappeared. Fortunes were built. Fortunes were lost. The story seemed finished. But here's the problem. The Earth never agreed to that conclusion. Because while we've been focused on the gold already found, something else has been happening beneath the surface. Quietly, patiently, almost unnoticed, the same geological systems we've been investigating, the hills, the drainages, the ancient transport networks, never stopped working. And today, for the first time in generations, those systems are becoming important again. Not because the gold changed, because the world did. Think back to our last investigation. We discovered that gold doesn't collect randomly. The Earth repeatedly guides it toward the same locations, certain valleys, certain drainages, certain geological structures. The landscape itself acts like a giant sorting machine operating over millions of years. And that raises an uncomfortable question. If those systems still exist, why would anyone believe the story is over? The answer lies in human behavior, not geology. For most of the last century, attention moved elsewhere. Cities grew, industries expanded, technology transformed society. Most people stopped looking at the ground. Gold became something stored in vaults, traded on screens, discussed by economists. The connection between gold and the landscape slowly faded. Yet the landscape never changed. The faults remained. The mineral systems remained. The hidden structures remained. Waiting. Then something began shifting. At first it was subtle, almost invisible. A few exploration projects reopening. Old geological maps being re-examined. Historic districts receiving renewed attention. Abandoned data being reviewed using modern technology. Nothing dramatic. Nothing that felt like a gold rush. But beneath those developments, a larger pattern was forming. Because modern exploration doesn't look like the gold rushes of the past. No wagon trains, no tent cities, no crowds racing into the wilderness. The new gold rush begins much differently. It begins with information. Imagine an old mining district that produced gold generations ago. Prospectors worked it. Companies explored it. Eventually, activity slowed. People assumed the story was finished. But then, modern geologists arrive. They bring satellite imagery, geochemical analysis, advanced mapping systems, data processing tools unimaginable to earlier generations. Suddenly, they begin seeing things that previous explorers couldn't. Hidden structures, overlooked trends, connections buried inside enormous datasets. And something surprising happens. The district starts looking new again, not because the gold appeared, because understanding improved. This is happening across the United States right now. Nevada, Alaska, Arizona, Idaho, Montana, Utah. Historic districts are being revisited with completely different eyes. And the results are forcing people to ask uncomfortable questions. What if some of the biggest opportunities were never actually discovered? What if they were simply misunderstood? That possibility becomes even more interesting when gold prices enter the picture. Because geology and economics are constantly interacting. A deposit ignored at one price may become extremely attractive at another. Ground considered uneconomic 20 years ago may suddenly become valuable. Not because the rocks changed, because the world changed around them, and that creates a fascinating feedback loop. As gold prices rise, attention increases. As attention increases, exploration expands. As exploration expands, discoveries accelerate, and every discovery raises another question. What else was overlooked? That's why today's gold rush feels different. It's driven by investigation rather than excitement, analysis rather than speculation, systems rather than luck. But there's another reason this movement is accelerating, and it has very little to do with gold itself. Security. Across the world, governments are becoming increasingly aware of the importance of natural resources. Critical minerals, strategic metals, supply chains, resource independence. These conversations are no longer confined to mining conferences. They're becoming national priorities, and whenever attention turns toward the ground beneath our feet, gold inevitably returns to the discussion, not only as a precious metal, but as a signal that deeper geological systems exist. Because where gold appears, other mineral opportunities often exist nearby. Entire geological provinces become important. Not individual discoveries, entire regions. Now imagine standing on one of those forgotten hills we discussed previously. A hillside most travelers ignore. A slope carrying the scars of ancient hydrothermal activity. For decades it attracted little attention. Then one day someone looks closer. The chemistry seems unusual. The structure appears promising. The data reveals something unexpected. And suddenly the hill enters a completely different story. Not because it changed, because someone finally asked the right question. This pattern repeats throughout mining history. The biggest discoveries rarely begin with certainty. They begin with curiosity, a strange anomaly, an unanswered observation, a hill that refuses to fit expectations. Exactly like the hills we've been investigating. And that's why the phrase, new gold rush, can be misleading. It suggests a rush toward gold. What's actually happening is something deeper. A rush toward understanding. A race to identify which geological systems still matter. Which districts still hold secrets, which assumptions were wrong. Because many of the easiest discoveries have already been made. The next generation of discoveries belongs to those capable of seeing patterns others missed. And that's where our investigation comes full circle. Think back to the very beginning. A hill nobody notices. A drainage carrying subtle clues. A system repeatedly concentrating gold. At first, those seemed like separate mysteries. Now they begin fitting together. The hill revealed evidence of mineralization. The river revealed evidence of concentration. The economic environment revealed renewed importance. 3 different stories, one underlying system, and that system is becoming increasingly relevant. Not because the Earth is producing more gold, because we're becoming better at reading the evidence. Now here's the fascinating part. Most people imagine discoveries happen suddenly. A giant nugget, a major drill result, a headline. But reality is often quieter. The discovery begins long before the announcement. It begins when someone notices a pattern, a structure, a contradiction, an inconsistency in the accepted story. And then they investigate. That's exactly what we've been doing throughout this journey. Not chasing treasure, following evidence. And the evidence is pointing towards something important. The great gold systems of America are not ancient history. They're active geological stories still being interpreted, still being explored, still being understood. Which means the most interesting chapter may not be behind us. It may be ahead of us, somewhere beyond a forgotten hillside, somewhere beneath an overlooked valley, somewhere inside a geological system waiting for someone to connect the pieces. Because the new gold rush isn't being driven by pickaxes. It's being driven by knowledge. And knowledge has a habit of turning ordinary ground into extraordinary discoveries. So the next time you see an empty hill, a quiet drainage, or a landscape that appears to hold nothing of value, remember what we've uncovered. The hills were never just hills. The rivers were never just rivers. And the gold was never the entire story. They were clues. Pieces of a much larger puzzle hidden across the American landscape. A puzzle that geologists, prospectors, investors, and explorers are still trying to solve today. And perhaps that's the most exciting realization of all. Not that gold exists, but that the Earth still has secrets left to reveal, and somewhere out there, the next clue is already waiting.